We are live, so we're going to go over 5.2. Which is basically three equations, I should mention that they're linear, and three unknowns. Okay? That's what we're going to be talking about today. I think I'm going to pick a different marker though. All right, so let's start with a nice easy one. X minus 2y minus z equals 1. Y plus 2z equals 5, and z equals 3. So Nathan, let's start with you today. How would you solve this? Okay, so we've already solved one of them, right? That was nice. But in the top one? The second one, right? We're going to put that z in right there. This becomes y plus 6 equals 5. Subtract 6. Y equals -1. And then it goes in the top equation. That in there, and this in here. So we're going to get x minus 2 times -1 minus 3 equals 1. -2 times -1 is 2. Positive 2 minus 3. -1, so we're going to add 1 to both sides, right? So x equals 1 plus 1 is 2. Okay? And if we wanted to write this as an order triple, we could do rather than as the 2 first, then the -1, and then the 3. So that's what we would call an ordered triple. Okay? So if I had a graph, if x was 2, y was -1, I'd be here, and then z would be 3. This marker would be sticking out of the board like this, and I would go 3 units, 1, 2, 3. So it would be approximately right here. Okay? 3-dimensional is hard to draw on a 2-dimensional board, right? Okay? When you get into calculus, you get to do a lot of 3-dimensional stuff. And it's really hard to figure out. No, it's not that good. At first, it seems a little tough. Okay? So let's solve one that's a little bit harder. How about x times 2y plus 3z equals 1. X plus 2y minus z equals 13. And 3x plus 2y minus 5z equals number 3. Okay? So 3 equations, 3 unknowns. This one was nice because you could kind of back solve, and it was nice. But this one, okay, so this one, here's what I'm going to tell you to do for steps. Okay? Use 2 equations to eliminate 1 variable. And then step 2, use 2 different equations to eliminate the same variable again. And step number 3, oh, we're off camera. Step number 3 is repeat as needed with a new variable. Okay? So, Maddie, it must be your turn. Does the x, the y, or the z seem like the easiest variable to eliminate?
I want to see the y.
The y, because first of all, they're all 2's, right? And they're plus and minus. If I label this number 1, number 2, and number 3, how would we eliminate the y's?
We want to take 2 equations first. So let's just do, let's do 1 and 3.
1 and 3. So you're gonna add 1 plus 3 together. Okay? So 1 plus 3. So x plus 3x is
4y.
4x.
Or sorry, 4x.
Negative 2y plus 2y. 0, so that drops out. 3z minus 5z. Negative 2z equals 1 plus 3, 4. Okay, so you've just done step number 1. Now let's repeat that with 2 different equations.
Let's do 1 and 2.
Yeah, let's add 1 and 2. So if we add these 2 equations together, x plus x is
2x.
negative 2y plus 2y. 0, that drops out. 3z minus z plus 2z equals 1 plus 13. 14. And that's going to drop out, right? That was nice. So I'm going to get 6x equals 18 divided by 6, x equals 3. Okay? Now we've got x equals 3. What do we do?
Plug it back into 1.
You can plug it back into which equation?
First. Oh.
And we got 2 sets now. Let's plug it into one of these 2, right?
Yeah.
Which one, top or bottom?
Let's do the top one.
Okay, so we're going to plug this into the top equation. So we're going to get 4 times 3 minus 2z equals 4. 4 times 3 is, so we're going to subtract 12. Negative 2z equals, no, just negative 8. Just like you said.
Z equals 4.
So divided by negative 2, z equals 4. Okay?
Now you have x and z.
And we can plug it into any one of the 3, right? Does it matter which one?
No.
Does not matter. Which one do you want to plug it into?
Let's do the first one.
The first one. So we're going to plug this x into here. We're going to plug that z into here. And we're going to get 3
plus 2y.
minus 2y
Plus 12.
plus 3 times 4, which is 12, as you said, equals 1. So 3 plus 12 is 15. So we're going to subtract 15 from both sides. Negative 2y equals 14 divided by negative 2, y equals 7. Okay, and you would write that as an ordered triple how?
You do 3, 7, 4.
Okay. All right, this isn't too bad, huh? Would you happy to do these all over? Are you leaving, Andrew?
Yeah, I got it.
Oh man, I was just gonna pick on you.
So that's like 5,
Huh?
just to make it time.
No, let's do that. Well, just burn that shirt when you leave.
Okay.
Okay. All right, let's do another one. How about x plus 2y minus 2z equals 1. 2x plus 2y minus z equals 6, and 3x plus 4y minus 3z equals 5. All right, just making sure I wrote it down right. Okay, so Demi, it must be your turn. Which variable looks easiest to eliminate first?
Just pick two equations, right? Probably.
Yeah, I need to.
First and the third.
The first and the third, 1, 2, and 3. Okay, so what are you going to eliminate?
X.
We'll
Did you
eliminate the
multiply
x.
the top equation by -3?
Okay, so if we multiply this whole equation by -3, this becomes, and I'm going to pick a different color. So -3 times x is
-3x
-3x
minus 6y
and 6y
plus 6
plus 6z equals -3. So now we're going to take these two together.
Mm-hmm.
We're going to add them together. The x's fall out. I'm left with
-2y
2y
plus 3z equals 2.
2. Okay? All right, now we get to repeat the same thing, but with two different equations. So you used 1 and 3 the first time.
Mm-hmm.
So we either have to use 2 and 3 or 1 and 2. And we're still eliminating the x again.
Oh, eliminating the x again.
Yeah, so once you pick one, you have to do it for the same variable again.
Okay. 2, 1, and 2.
Okay, so we're going to do 1 and 2. This time, rather than multiply by number 1 by -3, we're going to multiply by
-2.
-2. So -2 times x is
-2x
-2x
minus 4y
minus 4y
plus 4z
plus 4z
equals -2.
equals -2. And then I'm going to rewrite this down here. This is equation 1 and 2. This is 2x plus 2y minus z equals 6. Okay? So the x's fall out again. Then this becomes, I'm going to write the answer up here. How's that? -4y plus 2y is
-2y
-2y. 4z minus z
-3z
positive 3z equals
4.
4. Okay? So we're using these two equations. That falls out, and I'm left with 0 equals 6. And that's only true when? When I owe you money, right? Okay? So what does this mean? Means what?
No solution.
No solution. You could also say inconsistent. Okay? So it means that these lines never cross each other. Okay? All right. Now let's do, yeah, we got enough board to do one more before I switch back over. Let's do another one. Okay. How about x minus y plus 5z equals -2. 2x plus y plus 4z equals 2, and 2x plus 4y minus 2z equals 8. Okay? So, Cameron, it must be your turn. So, which of the two equations looks like, or which variable looks easiest to eliminate? The x's, the y's, or the z's?
Probably X's.
The x's. Okay, how would I eliminate the x's?
Well, we could multiply number 1 by 2, negative 2.
We're going to multiply number 1 by -2, and we're going to add it to,
Number 2.
so we're going to take equation 1, we're going to add it to equation 2, or actually I'll write this in. -2 times equation 1 plus equation 2. Okay? All right, so this becomes
-2x
And 2x
plus 2y
plus 2y
minus 10z
minus 10z
equals positive 4.
equals 4. And then I'll just rewrite equation 2 down here to make it easier. 2x plus y plus 4z equals 2. Okay? The x's cancel. We're left with 3y
Minus 6z
and 6z equals 6. Okay. So since we eliminated the x's, we can do it again. What's the best way to do that?
Multiply 3 by -1.
Okay, so you're going to multiply 3, or one way to say that would be, we're going to take equation 2 minus equation 3, right?
Yeah.
Should we do that? Okay, so we're using these two equations now. So 2x minus 2x is 0. Y minus 4y
Is positive 3y. Negative 3y.
negative 3y, right? 4z minus a negative 2z is,
2z.
it's actually 6z. 4 minus a negative 2. Okay, so 6z equals 2 minus 8 is negative 6. So that goes away, that goes away, and that goes away, and I'm left with 0 equals 0. Is that a true statement? Yeah. And so, what does that mean? No clue. Okay? What this means is basically you have a dependent system. And in fact, that's the answer that I would prefer. In the back of your book, you'll find something else. Because there's actually an infinite number of solutions. I'm trying to decide. Basically, these lines never intersect. Yes?
Does it mean that they're on top of each other? Going.
Yeah, usually what it means is two lines are multiples of each other, but I don't see that in this case. But you can see here, these two lines are identical. That's the same line twice, right? In 2 dimensions. So yeah, so this is a dependent system. Okay? So that is the end of 5.2. But since we still have time and 5.3 is going to be a much harder and longer section, let's get started on that. And it's based on this stuff too. So let's go with 5.3, which is partial fractions. Okay? What I'd like to do is come up with a little bit of a simple example first, and then this will give us an idea that we're going to do something a little bit harder. If I had 1/2 plus 1/3, and I wanted to add those together, what would I do, Joey?
You would times them by 2 or
We
3.
get a common denominator.
Yeah.
Common denominator is
6.
6. So what do I got to multiply 2 by to get 6?
3.
3. So I multiply by 3 over 3, because that's the same as multiplying by 1, right? Well, what do I multiply 3 by to get 6?
2.
2. So if we multiply that by 2 over 2, I haven't changed anything. 3 times 1 is
3.
3. 2 times 1 is
2.
2. I'm going to add those together, and I'm going to get 5/6. Okay? Now, the idea with partial fractions is I'm going to give you this fraction here, and I'm going to say, can you give me the original 2 fractions back? Okay? Only we're not going to do it on simple things like this. We're going to throw a lot of variables in that. Okay? So that's basically what we're doing. I'm giving you the answer and saying, can you give me what the original fractions were? Okay? Now, in this section, we're going to have 4 cases. We're going to do case number 1 today, and hopefully we'll have time to do cases 2, 3, and 4 tomorrow. Case number 1 are non-repeated linear factors. And in fact, let me do this. I'm only going to give you 4 of these to do. For your homework. So your homework is going to be all of 5.2. And in 5.3, I'm going to just give you 4 problems to do. And the 4 problems are number 3, (13), 14, and 16. Okay? So the nice thing is, one of those 4 problems will be your quiz question tomorrow. Okay? All right, so case number 1, we're going to talk about non-repeated linear factors. Okay, so this will work for all 4 of these problems I've assigned. So in the case of this, let's go ahead and we're going to do a problem here. And the problem is find partial fractions for 5x plus 7 over x cubed plus 2x squared minus x minus 2. Okay? So the first question is, Zach, can you factor the denominator? Let's do factor by grouping.
So on the first one,
Okay?
you take out an x.
Take out just an x. I could take out an x squared out of these first 2, couldn't I?
Oh, yeah. Which would leave you with x.
Which would be x
Plus
2. And then I bet I could factor out the -1 out of those 2, right?
Yeah.
And that would leave me with
x plus 2.
x plus 2. And then this becomes x plus 2 times x squared minus 1, correct? Can I factor this?
Yeah, x plus 1, x minus 1.
X minus 1. And I've got an x plus 2. Okay? So this factors into this. Now, do you see that each one of these factors, what's the highest power? 1. So these are all what we would call linear factors. Okay? And I've got 3 of them, correct? Okay? So what I'm going to do here is I'm going to create 3 fractions. One's going to be x plus 2. Another one's going to be x plus 1. And another one's going to be x minus 1. Okay? So at this point, okay, all right. So I've got 3 linear factors. And so once again, I want to emphasize this is case number 1. Okay, we're going to do some other ones where it's going to be a little different. And they're non-repeated. Okay? None of these factors repeats itself. Okay? So what I'm going to do is I'm going to put an A here, I'm going to put a B here, and I'm going to put a C here. Okay? So that's what we're going to do for case number 1. Non-repeated, all of them are linear factors. Okay? Now, Riley, if I were going to take these 3 factors here and I wanted to add them together, what do I need to do? Common denominator. And this happens to be my common denominator, right? Okay? So my common denominator is going to be x cubed, or rather than write it out this way, I'm going to write it this way. I'm going to use the factored form. X plus 2 times x plus 1 times x minus 1. Okay? All right, so in this case, okay, I want to get a common denominator, okay? What do I need to multiply x plus 2 by in order to get this whole thing? I think you're right. That was good help from Michael too. X minus 1 times x plus 1, right? Now, let's make this a little bit smaller, give myself a little bit more room. What do I need to multiply x plus 1 by to get this whole thing? X plus 2 and x minus 1. And same thing on the bottom, x plus 2, x minus 1. I forgot to do that over here. Okay? What do I need to multiply this by to get that? X plus 2, x plus 1. X plus 2, x plus 1. All right. So now that I've got this together, I'm going to have a common denominator, okay? So essentially, here's what I'm going to do. I'm going to FOIL this out. I'm going to get a times x squared minus 1 plus b times x squared plus x minus 2. And I'm going to get plus c times x squared plus 3x plus 2. Okay? So far, so good? Have I lost anybody? Okay. So at this point, now my denominators are the same. I'm going to ignore the denominator for now. Okay? I'm just going to FOIL this out. And so this becomes ax squared minus a plus bx squared plus bx minus 2b plus cx squared plus 3cx plus 2c. Okay? Oh, that's kind of hard to see with the shadow there. Okay? All right, so I've got all this thing. This is all over the denominator, which I'm not going to worry about at this point. Okay? All right, so the idea here is we need to make this numerator here look like this numerator over here, 5x minus 7. Okay? Now you'll notice I have some x squared terms in here. Okay? So I'm just going to write down the coefficients of the x squared terms. So I'm going to have an a plus a b plus a c, okay, equals, okay, let's go back here. I probably better change my thing back so we can see this a little bit. There we go. Okay, so do I have an x squared term in my original fraction? Okay, so I could write this as 0x squared, right? Normally I wouldn't do that. So the coefficient on the x squared term is 0, okay? So all three of these have to equal 0, okay? Now I'm going to do the same thing with my x term, okay? So Daniel, can you give me the coefficients of all of the x terms? So I don't have any here, but I've got this one. B. Sorry, that's a +3. I know that looks terrible. Bad handwriting. Okay, so this is 3c, right? Okay, and that has to equal the x term over here, and the x term over here is 5, okay? Now I have to do the same thing with the number term, okay? So, Hallie, what do I have left? Negative a, okay? Minus 2b plus 2c equals, now that has to equal my number term, which is 7. three equations, three unknowns. How do I solve this, Eunice?
Well, you can do everything in the last one. And subtract.
Okay, so the same thing that we just applied with the last one, right? So you said, so one, if we call this 1, 2, and 3, what, tell me what I'm doing?
We use, actually we can use 1 and 2. And just
Okay, if we add 1 plus 2, we can eliminate,
multiply the second and then
what are we eliminating? You're eliminating the b? Oh, okay, I see. Okay, so let me just show you a nice little shortcut here. There is no a here, right? So I've already got, if I take that one, now let's just eliminate another a. Because I could just take this one and this would be b plus 3c equals 5. Now if I can eliminate the a's somehow, how could I eliminate the a's?
Just eliminate, A's and is it just negative b?
So if we took equation 1 and equation 3, these a's are going to eliminate, right?
Yeah.
Okay, so if I take 1 plus 3, so a minus a is 0. B minus 2b, negative b. C plus 2c, 3c equals 0 and 7. 7. Okay? Now the b's eliminate. 3c plus 3c is 6c equals 12. Okay, so now divide by 6, c equals 2. Okay, so now I know that c equals 2. So now I can cross out this, and that is now 2. I've got one of my partial fractions already. Okay, now how do I find out b and a?
You can put it with, you can put it in C, so you can do B plus 3 times 2.
Do you want to use the top one or the bottom one? Probably the top one, right? We're going to plug in the c equals 2 there. So 3 plus 3 times 2 equals, sorry, that's b. B, that's a b. B plus 3 times 2 equals 5. So now I'm going to subtract 6. So b equals negative 1. Now that I know what b equals, b, I can cross that out with a negative 1, right? And then how do I find a? The first equation. So a plus b, b is plus negative 1, plus c, and c is 2, equals 0. Okay? So 2 minus 1 is, so if I subtract 1, a equals negative 1. Okay, so now I can cross out this. So making this more clear, my three partial fractions are negative 1 over x plus 2 plus negative 1 over x plus 1 plus 2 over x minus 1. Okay? So there you have it. Those are partial fractions. That will be very useful when you get to calculus. And if you're not in there, it will still be useful until you get there. Okay? Practical application of 3 equations and 3 unknowns. Almost guarantee one of these will be on the final exam. Okay? Now, we've only done case number 1. We're going to do case number 2 and 3. They have some slightly different steps. Yeah, so we'll talk about those tomorrow. So the quiz is on 5.2 and 5.3, these 4 problems. Okay? See y'all tomorrow.